Okay, let's look at this numerical. A car is moving with a uniform velocity of 30 meters per second. It is stopped in 2 seconds. Okay, so initial velocity of the car is 30 meters per second, and final velocity of the car will become 0 meters per second in time period 2 seconds. So the car is stopped in 2 seconds by applying brakes, and the force produced by the brakes is equal to F equals to 1500 newtons. Calculate the change in momentum, that is delta P. Second part, calculate the retardation. Third portion, calculate the mass of the car. Now let's start with the retardation first because it's the simplest thing to find over here. All the data is given to us. So acceleration equals to v minus u upon t. This is the formula for retardation. Final velocity is 0 minus initial velocity 30 divided by the time period is 2 seconds, so which is equal to minus 15 meters per second square. The negative sign over here indicates that it is retardation. So acceleration equals to minus 15 meters per second square, or we can say retardation equals to 15 meters per second square. Now that we have our retardation, or we can say acceleration, which is minus 15, we can find what is mass. We know the formula, force equals to mass into acceleration. The force is already given to us, which is 1500 newtons to stop the car. So 1500 newtons equals to mass of the car multiplied by the retardation produced, which is 15 meters per second square. So mass equals to 1500 divided by 15, which is equal to 100 kg. So the mass of the car is 100 kg. Now let's find what is the the change of momentum. Change of momentum equals to initial momentum minus final momentum. So we can say, mv minus mu. In this case, we can say which is also equal to delta P equals to mv minus u. We can take out m common over here, which is equal to, now we already found out the mass of the car is 100 kg. Final velocity is 0. Initial velocity is 30, which is equal to 100 in times 30, which is 3000 kg meters per second. This is the change of